Okay, here we are with our second patch video with the modular synth. And today we're going to look at a few of the modules that we've seen before. We're going to look at the Make Noise Rene, but we're going to add into that a look at the Make Noise pressure points and also the Make Noise maths, which is there under that tumble of cables, and the Wiard Anti-oscillator, which we're going to use as our sound source, and Mutable Instruments links right there. And here's what our final patch is going to. We're also going to take a little look at Mutable Instruments Clouds. And so we're going to go backwards from the patch this time. And this is what the patch sounds like that we're going to create. Okay, so what are we doing here? Now we're going to try and take apart that patch and see if we can recreate it. We might not be able to, because that's how things go with modular synths, especially when you don't really know what you're doing, like me. But basically, what we're going to do is we're using the maths, and the maths is a function generator. And if I take these cables out, I should be able to see a little bit better. Here we have the maths, and maths has 4 channels, and basically what we have is over here on the left side we've got the first channel. So that's the input there. That's a trigger. So the audio would go in there, although you could put in control voltage. It's got a button which says cycle, which allows you to set it to cycle, meaning when it finishes generating one envelope, it's going to go right back and recreate it, and you can do cool things with that. This is the trim pot, which can be used as an attenuverter. It can attenuate the circle. It can attenuate the signal coming in, meaning weaken it. So this would be fully open for channel 1. This is the trim pot for channel 1. This would be fully open. This would be closing it as you turn it counterclockwise. When you get it right in the middle, it's closed. And as you start turning to the left towards the negative, it inverts the signal. So that's the attenuverter right there. You've got a rise, which determines how the signal comes up if it's generating an envelope. You've got a fall, which determines how the signal falls. And then this changes the behavior of the channel from logarithmic to exponential. Sometimes that's, one is better than the other for audio, exponential versus for control voltage, logarithmic, but you can play with it, and this is a continuously variable knob, which allows you to get cool things. Now, you've got various outputs for channel 1. Your regular output, which is handled by the attenuverter here. Then you've got an S output here, which is the signal not attenuated in any way, the full amplitude signal. And then you've got something here that says EOR, that stands for end of rise, which means when the envelope finishes its rise, at that point it's going to send out a trigger. So on the right side, you've got the same thing mirrored. you've got channel 4, which is the same thing mirrored. You've got your input, your trigger, your cycle button, rise, fall. Oh, I forgot to mention there's a both in the middle that these have control voltages in, so you can change the rise and fall with these knobs, but you can also have control voltage in controlling and modulating the rise and fall through control voltage, and you have a both input, which allows you to modulate both the rise and fall together. So this fourth channel mirrors the first channel and goes out the 4 outputs, got a sum output, which is the maximum signal, not attenuated. Except instead of end of rise, it has end of cycle, which means instead of triggering when it reaches the top, it triggers when it reaches the end of the whole cycle. So that's useful because it allows you to have different types of outputs on those 2 channels. The 2 middle channels, channels 2 and 3, just have the attenuverters, and they have their own inputs 2 and 3. You can sum all those, so their own outputs 2 and 3. You can sum all the outputs into the summed output. So you can use this kind of as a mixer. There's also logic in this module of OR logic. This one says inv. Not exactly sure what that is, to be honest. But there's logic. I haven't really delved into that because, to be honest, don't really understand logic that well. But we can use maths in all sorts of ways. You can use it as a low-frequency oscillator, as an audible oscillator, as an envelope generator. You can use it for delay functions and so on and so forth. What we're going to do is we're going to use maths to trigger our sequencer, the Rene. So the Rene has an X clock input, which moves the signal to the right every time it gets a trigger or gate. It has a Y clock input, which will move it up or down every time it gets a Y clock input, depending on how you have it configured. So what we're going to do is we're going to take the maths, and we have here we have the quantized output of the Rene going into our oscillator, which is our sound source, which is the Wiard Anti-oscillator, and then we're going to have that output going into our output. So the output just sounds like that. That's just the straight output because the Rene is not yet being clocked. It hasn't been connected to the maths. So what we're going to do is we're going to take the maths and we're going to take its end of rise output from channel 1. We're going to cycle that. So what it's doing now is the maths is generating an envelope and it's cycling it. And you can see the speed of the cycle is right there, right? As we turn the rise and fall, you're going to see that that's slowing. I'm turning the rise to the right. You see how it slows down. As I turn to the left, it speeds up, right? There we go. So we're going to take that. Now that's generating this basically kind of like trigger. And we're going to put that into the X clock input. And now it is moving the Rene. So if we listen to that. Now you notice it's only moving it along the x-axis. It's repeating 1, 2, 3, 4, and then it repeats. Oops, just deactivated one of the steps. It's not moving it up or down because it's not getting anything from the Y clock. We haven't done anything there. So what we can do is we can have the Y be clocked from the end of cycle of channel 4. And we can have that cycle. And we can change that speed also. Now another thing we can do is we can bring the links in here so that the two are being triggered at the same time. What we can do is we can take, instead of having the maths go directly into the X clock of the Rene, we take that output and we plug it into links, which is basically a mult. That means it's a multiplier. And what links does is allows us to take that one clock coming from the maths, and we can take one output and plug it into the trigger input of channel 4, and take the other output of that same trigger from maths through links, because it's multed, and put that back into the X input of the Rene. Okay, so now what we have is we've got a kind of pattern that kind of has an internal logic of its own, because the end of rise from the maths, which is cycling, is coming to the links. It's being multed out to the X clock, moving the Rene this way, also to the trigger of channel 4 of the maths. Its end of cycle is going to the Y clock. Now, this is kind of still pretty static. So what we're going to do is we're going to take an LFO from the Batumi, which we saw in the last video, take a sine of that, and put that into some of the control voltage of the maths, which is going to change this a little bit. So for example, we could change the rise. Now you see, as the Batumi's LFO low frequency oscillator cycles, which is happening slowly, it's speeding up and slowing down the maths. Now that's changing it pretty drastically. So another thing we can do is put it into the cycle of the fourth channel of maths, which is affecting the Y clock. So you see how that introduces a bit of randomness, or a little bit more interest into the pattern. Okay, so now what we can do is we can bring the pressure points in. And what pressure points is it's got 4 touch-sensitive pads. And you see the light on it is moving as I press them. And depending on which pad I press, 3 CV outputs are active. So if I press this, it's these 3 that are active. And those send out CV, they send out control voltage through these outputs right here on the right. So the top one, for example, if I take that output of the top row and I put it into the Wiard Anti-oscillator here, into its frequency modulation, it's going to actually be a little clearer if I take the Rene out, so it's not sequencing the anti-oscillator. So we've just got a static, the Wiard anti-oscillator is just static right now. Now we look down here. It's on this channel right here. You see these are turned up a little bit more. So if I move to here, the pitch goes up. Now I can tune these anywhere I want. Now what this means is when I start the sequencer again, every time I change this, it's basically going to transpose the sequence up by this amount of pitch. So if I put this back in to the 1 volt per octave input, there, we've got our sequence going again. Now you hear as I press these buttons, it's going to start transposing it upwards. Okay, you notice that there's also these other rows here that I'm not using. They also have CV outputs. So let's say we took one of those, took that second row of outputs and put it into the rise and fall of the mouth. So that's going to change the speed at which it's cycling. So it's right here, it's at the lowest setting, so we hear no change. But as I move it here, it's not only changing the pitch up, that's this row, because we have that going into the Wiard Anti-oscillator, but the second one's going into the both of mask channel 1, which is triggering the X clock of the Rene. So you hear, because this is higher, it's speeding that up. Now this is back down again, so when I go here, the pitch goes up, but I'm back down to my original speed. And then I could set this one really fast. So you can really control anything with pressure points, anything that takes CV, you can set it. This one's doing pitch, this is doing the speed of the cycle. You could use this one, for example, to open and close a filter. If we were using a filter, we're not doing that right now. The other interesting thing is that these also have gate outputs and pressure outputs. So when you press this, it can also trigger something if you were to connect a gate output. And the pressure has to do not with real pressure, but with how much of this you're pushing down, how much of the pad you're pushing down. And you can use that to control something. Using that to open and close filters is pretty cool. So this is our basic patch right here. Just to make it sound a little better, we've got it going into Clouds, and Clouds is a granular synthesizer. And if we just open up Clouds a bit, the blend, we're going to hear that kind of reverb-like effect of Clouds. What Clouds is doing is it's taking little bits of that input and then it's playing it back. And you can put the pitch up. This is the pitch knob right here. And that means when it plays it up, it's going to play it up as a higher pitch, and that's why you're hearing those sounds come in at higher frequencies. And now we can manipulate this with the pressure points. Another interesting thing is to just explore the Wiard Anti-oscillator. We've just been using it in a pretty straightforward way, but it's got a lot of cool sounds in here. You've got here the initial wave and wave envelope controls, and as you start affecting these, you start getting very different sounds. These different tones are even more noticeable when using the Mayhem output rather than the standard triangle output. could actually modulate some of those changes in timbre by taking an output from the Batumi, one of the sine wave outputs, so now we're changing that timbre there. Okay, so that's our basic patch right there. It's not exactly where we started off with, but we explored in a slightly different direction. So that's it for now.